Well, good morning, my peeps. So here we are in our second week of talking about exponent rules, and now we've learned all of our 9 exponent rules that we're going to make a video on later in the month, actually in February. But now we're looking at polynomials. Poly means many, and nomials is number. So we're looking at polynomials and monomials. First, we're going to take a look at monomials. Monomials means one, or one value of a number, right? So 5, that represents one value. It could be 5 stars, 5 cars, whatever, but it represents 5. X represents a number as well. It is also a monomial. Negative 4x is a monomial because it's -1 times 4 times this number that we don't know. 3 times x times y squared also represents one value. You can think of these all as just like one person. One person might represent 5. One might represent x. One maybe is like 3x y squared. Here we have half of 4x to the 4th. Half of x to the 4th. Let's look at things that are not monomials. They kind of look like they could be monomials, but they're not. Like x to the -2nd power, because that actually equals 1 divided by x squared, meaning that it is 2 numbers, 1 and then the operation division and then x squared, right? So it's actually 2 things happening here, right? Now remember, when we think of multiplication back over on the other side, all of these guys, it's okay that they're multiplied, right? It still represents one value. Okay, I just want to clarify that. But division is something separate. So if I have 2 divided by x to the 3rd power, there's 2 things happening here, right? We are dividing, but we're also multiplying. So that's not going to work. Now, this is really where it counts. These are obvious because we have 2 values here. We have 4 times x and we have y, and we're subtracting. So we talk about this all the time as 2 people in the family. These are 2 separate identities in one grouping, right? We could also say plus y. It's still 2 separate values, or 2 people in a family. So let's just talk about the degree of a monomial, just one value. We represent the degree according to exponent values, right? Except anything to the 1st power, we don't actually include that as that it's an exponential value because it's just representing itself, right? So we would say that it's 2 plus 4 is 6. That this monomial 2a squared b to the 4th power is to the degree of 6. Or we know that we would have to do a twice and b 4 times, and 4 plus 2 is 6. This value right here, 4, is just to the 1st power, right? We know it's to the 1st power, but because it is not, it does not have an exponential value, we would just say that it doesn't have a degree. It doesn't have a degree. It's to the 0 degree. Now, that does not mean it's to the 0 power, because we know anything to the 0 power is 1, right? Let's look at this value. We have -8y. Well, we know -1 in the beginning there is to the 1st power, and 8 is to the 1st power, and y is also to the 1st power. But we would say this represents 1. Because this unknown value of y, we're going to go ahead and say it's to the 1st degree, because we don't know what it is yet. Now, go ahead and find the degree of these monomials. They're numbers, but they're monomials. Super important to remember that, right? So number 1 is just 1, right? And number 2 is going to be 2 plus 3 plus 1 is 6. All right, now let's talk about polynomials. And polynomials are just more than one monomial, or we're talking about people in a family, right? So if I have 4x plus 2, this is 2 people in this family, or it's a binomial, right? 2 terms. This is a trinomial because it has 3 terms, or I like to say 3 people in the family. And any more than that, we call it a polynomial. It doesn't matter if it has 4 or 5 or 6 or 7 or 12. It doesn't matter at this point. Anything more than 3 is called a polynomial. Let's go ahead and write the polynomials in standard form. Well, what does that mean? Well, that means we want to write the highest degree of monomial first, right? So we could see that the degree here is 1 for the first one, 3 for the second, 0 for the third, and 2 for the last one. So we put them in highest degree first, right? I like to say the head of the household. So negative 4 x to the third goes first, then negative x squared, then 20x, and then 2. This is in standard form. The lead coefficient, or the head of the household here, is negative 4. So we put them in standard form, putting them according to degree, and often we want to identify the lead coefficient. Also, the lead of this polynomial determines the degree. So the head of the household, that negative 4x to the third, has a lot to do with what we think. Lead coefficient, it will later tell us whether this is how this line will curve. So it's very important. And also, well, it's kind of a little bit like slope. It'll tell us which way it tilts. And then the degree will tell us how many times it crosses over the x-axis. But that's a whole other thing. So let's go ahead and learn. So right now we're learning the skill of putting them in highest degree first, right? So yeah, you can see this is going to come first, followed by this, third, and fourth. And we just rewrite it in standard form, and we identify the lead coefficient here as 1, right? And the degree of this polynomial is 5. Go ahead and try these. Don't forget to give the lead coefficient and the degree of the polynomial. If you're watching at home, pause the video here and then check your solutions. Hopefully this is what you got. Don't be confused. Just because it's a negative coefficient doesn't mean that it can't be the head of the household, right? All right, for 6-3, you're going to be doing textbook 1 through 26. And you're also going to be doing the scientific notation. If you're doing this at home, scientific notation puzzle is what we did as a warm-up in class. I have one more lesson for you today. We're going to do 6-4, adding polynomials. And honestly, it's just combining like terms. So make sure you watch the second video coming up.